Well, hello guys, here Mr. G with another video. This time is a question for grade 11. However, very applicable for the grade 12. So it's for both grades. This is question 3 done on the Eastern Cape in 2022 November paper 1. So we're going to do this question, but before we carry on, subscribe for the channel so you can get all the notifications and videos I post on regular basis, and please give a like to the video. But this question say two blocks of masses 5 kilograms and 2 kilograms are connected by a light inextensible string. A force F is applied on the 5 kilogram block at an angle of 20 degrees on the horizontal, and the system of blocks accelerate to the right at 2 meters per second square. So the acceleration, and we are going to write it here, the acceleration is equal to 2 meters per second square, and I'm going to just write this direction there, which is let's write right inward, just in case, as shown in the diagram below. The kinetic frictional force on the 5 kilogram block is 10 Newton. We have that the frictional force for this specific block is equal to 10 Newton and is going to be left. You know, if the object is moving to the right, then the frictional force will be pointing to the left. So this is the system, that is what you have here, and the question says define the term normal force. And the definition states that the force, the frictional force, the normal force is the force or the component of a force which a surface exerts on an object in contact with and which is perpendicular to the surface. Guys, definition must be learned. Nothing to say about that. There is no other way, but you have to learn the definition. If you state this definition correct, you will get 2 marks, and in this case it's 2 marks or nothing. So you have to say everything that is here. So you have to say is the force which a surface exerts on an object and is perpendicular to the surface. Those are the most important part of this definition. Question 3.2, draw a free body diagram of all forces acting on the 5 kilogram block. So we're going to do that one real fast here on the left, and it may happen that we have to do another free body diagram to understand the question better. So here we are, and then we have here the object is going to be this dot. What forces are acting on that object? We have the applied force F. You can write F there. We have the normal force pointing straight perpendicular to the surface, or in this case is up there. We have these are vectors. Let's write the vectors. We have the weight of the object which is pointing down, and we have the frictional force which is in the opposite direction of the object, and we also have the tension of the rope. This tension, I'm going to do it with blue so you can see both forces there. Note once more, you have 5 marks for that question. Therefore, there must be 5 forces, 3, 4, and 5. Instead of W, you can, for instance, write FG, and it will be fine. It will be no problem. The problem is not the symbol itself, as long as it's a accepted symbol. However, this is the free body diagram. If you by mistake include an extra force, guys, you will be penalized with 1 mark. That is question 3.2, and it's quite simple. Question 3.3, calculate the tension in the string, and then to calculate the tension in the string for this specific work, we have to work simultaneous most of the time. If you don't work simultaneous, you lose most of the marks. I'm telling you, I've been marking the exam, so you have to work simultaneous. Let's go and do question 3.3.1 on this side here. 3.3.1, and we are going to work simultaneous. What I mean by simultaneous, I mean that we have to work with both blocks. Now, in this case, we are going to begin with the 2 kilogram blocks. Why? Because there are less forces acting on the 2 kilogram block, and if you start from there, it may happen you don't have to work with the 5 kilogram block. So to do that, we are going to write here for the 2 kg, we are going to do the free body diagram for that one, because we need to know what forces are acting there. So in this case, we are going to draw the axis. I do like to draw the axis. This one is the y-axis. There is not x because the 2 kilogram block is moving in the y-axis only. And then what forces are acting there, guys? Very easy. The only forces there are tension pointing upward, which is the same tension that is acting on the other block, and we have weight pointing down. So this is the two forces acting there. So we are going to apply Newton's second law to this 2 kilogram block. So we come here and we say Newton's second law is net force is equal to ma. We apply Newton's second law because the object is accelerating. What forces are acting there? Now, in Newton's law, it's recommended to use the direction in which the object is moving as positive. So I'm going to write up positive because this specific object is moving upward, okay? So we come in here. What forces are acting there? Tension, which is positive, minus weight, which is negative because it is pointing down, multiplied equal to mass multiplied by acceleration. Now we don't have weight, but we know that weight is the product of mass and acceleration due to gravity. This is equal to ma. I am going to substitute now what I have, which is almost everything. Tension minus 2, that is the mass of the block, 9,8 is equal to 2 multiplied by the acceleration, which is given to us and is 2 meters per second square. And this is simple calculation. We get the tension is equal to 23,6 Newton. Guys, good news. We didn't have to work simultaneous. That is the answer to the question. However, if it was not enough because we have two unknowns, then we would have to go to the next block. But that was quite simple. Now, the next question is question 3.3.2. Calculate the force F as shown in the diagram. Now, to calculate force F, we must work with a 5 kilogram block because force F is acting on the 5 kilogram block. Once more, we are going to draw the free body diagram to work with that free body with that specific block. So let's go to a new page. There's no space here. So here we are, and we're going to draw the free body diagram for the 5 kilogram block. Guys, here we're going to draw the axis. It's recommended to draw the axis. This one is to understand, guys. As soon as you understand the work, you may not have to do it anymore. Remember, this is for explaining purpose, okay? So you can get the idea. What forces are acting, guys? We already did the free body diagram without the axis. So we have here F, which is in actual fact the question mark. We have tension here, pointing backward, which we just calculated, and along the same line here we have friction. It doesn't matter which one is first and which one is second. We have the weight here, and we have here a normal. We have here a normal. Remember, the force, the applied force, this force F, is in none of the axes. So actually we have to take it to the axis, and let me fix this one here because it's going to be a little bit short. This is x-axis. So when you extrapolate this one and you break it in two components, you have here F in x, which in actual fact is going to be equal to F multiplied by the cosine of theta. Theta is this angle which is given to us, and you can see that the F in x is the adjacent side to that side there. When you break the force in the perpendicular component or in the y-axis, you will get here F in y, which in other words is the same as this one here. This will be F in y, and you can see that is a y, not a g, be careful. F in y, which is equal to force multiplied by sin of 20 degrees. You can see it's opposite side. So this is important. Now we are looking for F. So to calculate F, we can either use the F in y or the F in x. However, if you note, if you quickly have F, real fast quick, we don't have the normal. So we will struggle because we will have two unknown. So rather, let's work in the x-axis. So we're going to work here because we have all the variables there. We have all the physical quantity. We know all of them. So doing that, we're going to apply Newton's second law once more to the x-axis. So we come in here, we say F net is equal to ma. All right, we are working for the x-axis, and as I said before, this object is moving to the right, so right is going to be positive. All right, that is very important to note. Therefore, all the forces that are pointing to the right will be positive, which is, for instance, Fx, and all the forces pointing to the left will be negative, which is in this case frictional force and tension, and this is equal to mass multiplied by the acceleration. So if we substitute, we don't have this Fx, but we know how to calculate it. All we have to do is to substitute it there, or you can calculate it here and then calculate later, but I think we can substitute. So it's F multiplied by the cosine of 20 degrees minus frictional force minus T equal to MA. Now we can substitute all the values because we know all the values. F is unknown, is what we're looking for, cosine of 20 degrees minus frictional force, which is going to be 10 Newton. We don't need bracket there. We don't need bracket there. It's unneeded. Minus tension, we just calculated, remember, and we got for tension 23,6. So minus 23,6 equal to the mass, which is in this case 5 kilograms. I'm looking at my notes. Yes, 5. And the acceleration is 2. We have everything there. So when you do the calculation, you will get that the force is going to be equal to, let me move it a little bit here, the force is going to be equal to 46,398, so okay, 46,4 Newton. And now we have to go quickly back to the question. The question said actually calculate the force. Force is a vector quantity, which means it have direction. So we are going to write, the correct way of writing this one will be 46,4 Newton at 20 degrees to the positive, let's fix positive, x-axis. There we go. Using the axis, that could be a way of writing the direction, but the direction must be there. Note the force is not to the right because I have an angle, guys. It have an angle, so it cannot be to the right. That one is this calculation, and I hope you understand it's quite simple. And then to finish the question, they say calculate the coefficient of kinetic frictional force on the 5 kilogram block. And we are now back to this page here, 3.3.3. Calculate the kinetic coefficient of friction. There we go. Now, what formula can we use to calculate the kinetic coefficient of friction? If you come to forces here, guys, you have a force with a formula which is this one. This one is the one that can help us to calculate the kinetic coefficient of friction. Let's write it exactly as it is in the formula sheet here, which in this case will be equal to kinetic coefficient of friction will be equal to frictional force divided by a normal. Now, we do have the friction, however, we don't know the normal. How do we calculate the normal? We have to go to the y-axis. Be careful because normal do not have formula. So you come here back to this free body diagram. Normal is in the y-axis, and therefore we are going to work with the y-axis for the normal force. All right, so what forces are acting there? We have the applied force in y, we have the normal, which is what we're looking for, and we have weight. All those forces are there. They're pointing in different directions. The object is not moving in the y-axis, so we're actually going to apply Newton's first law. But important, because it's not moving, either direction you take will be correct. Just to make our work a little bit easier, we're going to take up as positive in the y-axis. Let me write here up. But it doesn't really matter. Now here, guys, we are going to apply Newton's first law. You don't have to write it like this if you don't want. You really don't have to. Okay, we can write here that we have applied force in the y-axis. This is plus normal force minus weight, that is equal to 0. And when you rearrange this one, you can have that normal force is equal to weight minus force in the y-axis, which we also don't have, but here you know how to calculate it, that we already spoke about that. So we can substitute that formula here. We have the normal will be equal to weight, which is mass, multiplied by acceleration due to gravity, minus a force, which we did calculate already here, and then multiplied by the sine of theta, which is 20 degrees, and let's therefore substitute here 20 degrees. So the rest is just substituting for normal. This one is a 5, this 9,8 minus the force, which is what we got here, 46,4, multiplied by the sine of 20 degrees. So normal force is equal to, you'll get that this 33,13 Newton, and now we can substitute in that formula there. And so let's do that. The kinetic coefficient of friction will be equal to frictional force, which is 10, divided by the normal force, which is 33,13. The answer is going to be 0,30. I hope you understand, guys. This is the answer, and this is the end of this question. It is a very good question, not only for the grade 11, but also for the grade 12. So I hope you understand. Thumb up, please. Subscribe for the channel. Next time we're going to solve, let me show you Newton's law. We're going to solve this question, which is also Newton's law. We'll speak about this one later on. Thank you for watching, guys. I hope you understand. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.